We are given two damped oscillations with their time period and beta is given. So T1 and beta 1 is given and T2 and beta 2 is given. We need to find which of them decays faster. So when we talk about decaying, we talk about amplitude and not the displacement. So the answer of this question can be given in two different ways. So one is, if we look at the absolute time, we need to see which one of the two decay faster. So let's start first with the assuming some amplitudes. So let's say A1 is A e raised to power minus beta 1 t and A2 is A e raised to power minus beta 2 t. I am taking the same amplitudes so that it's easy to see which one of them decays faster because they are starting with the same amplitude. So now, like I was saying, the way in which they are decaying can be observed in two different ways. One in terms of absolute time. So at a given time t, which one of them has decayed faster? And second way to measure the decay is in one time period. So in how much the first one has decayed in T1 and how much the second one is decayed in T2. So that is another way we can find out in one time period how much the first oscillation has decayed and in one time period how much the second oscillation has decayed. So let's find both the answers. So initially when we are talking about absolute time, then we just need to compare these two. So here A is same, small t is same. So beta determines which one will decay faster. And we know higher beta means less amplitude. So if beta is higher, that one will decay faster. So in these two, 1 and 2 that are given to us, so in 1 you can see beta is higher. That's why 1 is decaying faster. And second one, beta is less. So second one will decay slower. So here we are talking about absolute time t. So in a absolute time t, we can see, so they started at the same point and this decayed less and this decayed more. Now second way to find the decay is in one time period. So time periods are different. So here time period is less in one. So first one will complete its cycle quickly and time period of second is larger. So it's almost like 100 times larger. So that will be like this. So its time period is pretty large of second. So now let's see which one decays faster in one time period of each of them. So that means when we are talking about time period, we need to put T1 here and we need to put T2 here and then we need to compare A1 and A2. So when you put T1 and T2, A is still the same. So let's compare beta 1 T1 and beta 2 T2. So beta 1 T1 is 10 and beta 2 T2 is 100. So beta 2 T2 is larger. That means A2 is lesser than A1. So A2 decays faster. So in this case, 2 will decay faster. And you can see in the diagram also. So in one time period, this has decayed more than this. So let's read that. But in terms of time period or phase, oscillation with larger beta t decays faster. That is for one time period, e raised to power minus beta 2 t2 is less than e raised to power minus beta 1 t1. Therefore, 2 decays faster in one time period. So our answers are different based on the absolute time or based on one time period of each. All right.